Alrighty, so today we're going to look at two different things today. We are going to first look at area between curves expressed as a function of y, and then we are going to look at area between curves when we have more than two intersections for that. That'll be 8-6 that we'll do after we do these problems. So what we have done so far, this is just a little recap, is if we needed to know the area between two curves and we had f of x and g of x, we would be looking on whatever limit, like from a to b here, and we would find the area under the top curve, and then we would subtract the area under the bottom curve, leaving us with the area that we're looking for, right? So whenever we're doing that, we would set it up like this: integral from a to b of f of x minus g of x dx. So what we're going to do different today is we're going to be given equations, or sometimes they're not given in terms of y, but we're going to be doing equations where they are not solved for y, they're solved for x instead. Okay, so let's look at example 1 here. We are supposed to find the area of the region bounded by the graphs of x equals 3 minus y squared and x equals y plus 1. Okay, so we don't have x equals equations, we have y equals equations. I said that backwards. We don't have y equal equations, we have x equal equations here. Now, this equation is very easy to solve for y if I wanted to. I'd just subtract the 1, and then y is going to equal x minus 1. So sometimes you may just want to change it back to y's because you think it is easier. It would work really well with this one. This one, not so much. Because if you try it for this one, you may not want to write this down, but just to see, you would subtract that 3, you would get x minus 3 equals negative y squared. You would divide by the negative 1. That's going to give you 3 minus x equals y squared. But then you've got to square root both sides, and this is something we ran into on the last FRQ of the test. If you square root both sides, what do you have to put with it? A plus or minus. And so now y is going to equal plus or minus the square root of 3 minus x. And that is not even a function anymore. And it's going to be much harder to deal with in the picture. So it's not, it can be done this way. It's going to have to be set up like a piecewise function almost. It's going to be much easier to do this one in terms of y. I'm going to erase this right here just for space reasons. So let's first get us a graph of these two functions, okay? Actually, before we even do a graph, it'd probably be helpful to know where these cross, right? Because if I know where they cross, then I can kind of know what I need to do on my graph, right? Where I need to go from like negative 5 to 5, or do I need to go from 0 to 10, or what do I need to graph? So if I want to see where these cross, what do I do? Set them equal to each other. They're solved for x this time, so we'll have y's instead of x's, but we just set them equal to each other. So we'll have 3 minus y squared equals y plus 1. And so let's move everything to one side. We'll get a positive y squared plus y, and we'll get a minus 2. And we will factor that, and that'll be a plus 2 minus 1. So that will give us y equals negative 2 and y equals positive 1. So if I'm trying, the graph is not, once you get, I think the graph is helpful because it's hard to picture these, but you don't necessarily have to graph it, but I'm going to. So definitely I need to go from negative 2 to positive 1, and we'll see. Oh, wait. I just put negative 2 to positive 1 on which axis? My x. Is that where I'm supposed to go from negative 2 to positive 1? It is not. I'm supposed to go from negative 2 to positive 1 on my y-axis. So actually, I might need more or less on my x. I might have to adjust that. Oh, wait. Let's see. We'll just see if this will work here. So if I want to graph x equals y plus 1, it's just a whole lot easier to solve it for y and graph it like a line. You have a y-intercept at -1 and a slope of 1. So that's going to be this line right here. I actually think I need to go a little further on that x-axis. It's about right here. That'll be, yeah. Okay, so I've got that line. Then I've got to graph x equals y, or 3 minus y squared. So you might know what that looks like. It's a sideways parabola, okay? It's a parabola because it's x squared, or because it's y squared, but since the y is squared instead of the x, it's going to be sideways for this. However, we learned a little bit about that in pre-cal, but I doubt anybody was like just so great at it they can just boom graph it right now. So if you're not sure what to do, just make yourself a table, but plug in y's instead of x's. So if I plug in, like, I know my y's need to go from -2 to +1. So if I do -2, 3 minus -2 squared is going to be 3 minus 4, which will give me -1. So I've got the point -1, -2, which is right here. And then if I plug in -1, 3 minus -1 squared is just going to be 3 minus 1, which is 2. So I've got a 2 here, so I've got 2, -1, that's right here. I'm going to plug in a 0, so 3 minus 0 squared is going to give me 3. So I get 3, 0, that's right here. And then if I plug in 1, I've got 3 minus 1 squared, which is also going to give me 2. So 2, 1 is right here. So what this is going to look like is this right here. Now, hello? I do. Yes. You're welcome. I also need you in guidance with your computer. All right, so this problem right here, like I said earlier, it can be done with x's. It is hard to do this with x's because if I'm thinking top function minus bottom function, which function is my top function? The blue or the red? Right here it's not. Right here it's the blue. The blue, because we're looking at this yellow area, right? Right here, blue is on top and red is on top until you get to right here. Which function is top and bottom here? Red is both top and bottom, right? So it can be done, but you got to split that into a positive square root of 3 minus x and a negative square root of 3 minus x, and you got to do 2 different integrals, and it's much harder to do this one with x's than it is with y's. If we do this in terms of y, if we take our derivative in terms of y, we are not finding the area, below the curve. We're finding the area to the left of the curve, the distance between the curve and the y-axis, not the curve and the x-axis, okay? So if we do this problem in terms of y, we don't want to think about the top and bottom function. We want to think about the furthest right and the furthest left there. So which function is furthest to the right on this, red or blue? Red. And is it always furthest to the right in this shaded area that we're concerned with? It is, right? It's always to the right, and the blue is always to the left, right? So if you think about what we're doing here, when we find the area under the curve for the red one, we're finding this plus, actually this is going to be like a little tiny negative area right here. But then we are subtracting out this area here. I really still shouldn't have highlighted that though, I think. It'll take care of itself. There. So we're finding this area and we're subtracting out the area under the blue curve there, which is going to give us this. So on the other ones, we have done top function minus bottom function. If we're doing this in terms of y, we need to integrate, I'm going to put just a general form, from a to b, the right function minus the left function with a dy over here. Also, these limits right here, our a and b, they come from our y-axis, not our x-axis. They come from our y-axis. So if we're going to set this one up, here's what it's going to look like. My right function is the parabola, which is 3 minus y squared. So I will be integrating 3 minus y squared minus the left function, which is the blue line right there, which is y plus 1. And this is in terms of y instead of x, so I put a dy over here. If you have a dy out here at the end, that means the y-axis is what you're looking at. You're looking at the distance from the curve to the y-axis, not to the x-axis, and your limits need to come from the y-axis. So our point where these two intersect right here, our lowest y-coordinate is at -2, right? That was our lowest intersection. So we go -2 up to +1 here. Actually, +1 right here. That's our highest. So I'm looking at, let me mark these points right here. I'm looking at this point, which was our intersection here, and that is at -1, -2. I'm looking at that y-coordinate there, and then our highest intersection point is right here. It is at 2, +1, and I'm looking again at the y-coordinate of that intersection, not the x-coordinate. So that'll go to 1 right there. Okay, so if we put this together to evaluate, once you get it to this point, it's the same as what we were doing yesterday, except for using a different variable, right? You're just integrating here. So we are going to have, let's do -y squared. We're going to distribute that negative right there, minus y plus 2 dy, integrate from -2 to 1. And so that is going to give us y to the third. We'll have a -1/3 out front. Minus, this is going to be y squared. We'll have a 1/2 out front plus 2y. And we will evaluate that from -2 to 1. Are we okay here? And so we're just going to plug these in here. And so this is going to be -1/3 minus 1/2 plus 2. And -2 to the third is -8 times -1/3 is going to give me a +8/3 right there. This is going to be a +4 times a -1/2, which will give me a -2. And that'll be a -4. And so that's going to be negative 1/3 minus 1/2 plus 2 minus 8/3 plus 2 plus 4. I would put this negative 1/3, what's that? Negative 8/3, which gives us negative 9/3. So that's just negative 3 minus 1/2, and 2 and 2 and 4 is going to give us 8. So we get 5 minus 1/2, which is 4.5 or 9/2 there. I went through all that arithmetic kind of fast at the end, but on an FRQ, of course, you can stop right here unless you need it to answer something else for the question. For that multiple choice, you're definitely going to have to get it down to that 9/2. So it's very similar to what we were doing yesterday, but we're going to have y's, and we got to be thinking the right function minus the left function rather than top function minus bottom function. So let's look at this problem. We are supposed to find the area of the region bounded by the graphs of x equals y to the third, x equals 4y, y equals 0, and y equals 2. This is definitely going to be a calculator inactive problem, but I do think it's helpful to see what is happening here. So let's look at this on Desmos just to picture what we would see here for this. We would have x equals y to the third, and I'm picking Desmos because Desmos will graph this. Your calculator, you have to solve things for y before it'll graph. And y equals 0 and y equals 2 here. So if we're looking at this, if they had just given us these two equations without the y equals 0 and y equals 2, we would have two sections that we'd have to look at, right? We've got two places that we'll have to look at there. But they told us just to look from y equals 0 up to y equals 2. So what we're finding is this part right here in the graph. We're only looking from here up to here. So we're looking at this part of the graph. We're looking for that intersection. Which function should come first? Okay, the x equals 4y. That's our blue line right here, right? And it is furthest to the right. Now, this can be done in terms of x, and if it's in terms of x, you got to do the red minus the blue, right? In fact, I may set this up both ways so that you can see it. I'm going to put this graph over here so you guys can. Let's see. That's not what I want. Just to make this one. So we are looking for this area right here. And because our equations are already in terms of y, I would just do this one in terms of y. So furthest to the right is going to be the 4y. Now, we graphed this on Desmos, which is a little bit of a cheat because we really would not be able to use a calculator on this. So you may or may not be able to tell what your intersection points are from that. You can kind of guess it's probably going to be 0 to 2. But you could, if you needed to, set these equal. Y to the third equals 4y. How do I solve that? For y on the other side, I got y to the third minus 4y equals 0. Then take out a y. So you got y squared minus 4 equals 0. You're setting each one of those equal to 0. Y equals 0. Y squared minus 4 equals 0. So y squared equals 4. What do I need to do there? What do I get? Plus or minus 2 for that. So you're intersecting at -2, 0, and +2, but they're telling us just to look from 0 to 2. This could be helpful because if, let's say, we got 0 to 1, then it'd be a little more complicated. We'd have to do something else. But it gave us these limits. We're just going to look from 0 to 2. So in terms of y, we'll be integrating from 0 to 2. And we will be doing the right function, which is 4y, minus the left function, which is y to the third, in terms of y. Yes? You can. So if you're not sure, because in this case you would not be able to graph it. So between 0 and 2 you could pick a number like 1, right? So if I do x equals 1 cubed, I would get just 1 for that. That's on my cubic one, right? But if I do x equals 4 times 1, I get 4. That's the bigger number. So this one is on the right. There. So you could also plug in numbers. That would be a good strategy because you wouldn't have a graph for this. There. For this, if we integrate here, we'll get y squared. 4 divided by that 2 is going to give us 2. And then we're going to get y to the 4th. And we'll have to have a 1/4 out here. And we will be evaluating this from 0 to 2. So that will give me 2 times 2 squared minus 1/4 times 2 to the 4th minus 2 times 0 squared minus 1/4 times 0 to the 4th. All of that last stuff just equals 0, so we don't have to worry about it too much. This is going to give me 8 minus 2 to the 4th is 16. 4th of that is 4, and we will just get 4 for our answer. Now, I'm not going to solve it, but I do just want to show you do have options on how to solve this. You could take both of these equations and solve them for y. So if you did that, you would cube root both sides. And you don't have to put a plus or minus when you cube root because you can take the cube root of a negative. So this equation right here could be y equals the cube root of x. And then over here you could divide by 4, y would equal 1/4 times x. Right? So if you do this in terms of x, you would do top minus bottom. Which one's our top equation, the cube root or the linear function, if we're looking at that graph? The cube root. That red graph is on top. If we're doing it in terms of x, we do top minus bottom. If we're doing it in terms of y, we do right minus left. So top would be the cube root of x. So you would be integrating. You'd have the cube root of x, and the bottom would be this 1/4 x here, and it'd be in terms of x. What would the limits need to be if you do it that way? I think it's 8. I think you're probably thinking the right thing, and the graph's just small. You're looking for this intersection point right here, and that is at 8. So you do 0 to 8. This will work, but I would rather do it this way. Number one, you don't have to solve your equations, right? You just use what they give you. Plus, I don't want to integrate the cube root of x if I don't have to, when I could just do y cubed. It's a little bit easier to do. So, in general, if they give it to you in terms of y, it's probably going to be easier to leave it in terms of y, but it could be done this way. I'm not going to do the work, but this will give you the same answer. There. Some problems can't really be done that way because they can't. The one we just did can't be done both ways very easily anyway. This one could be done fairly easily either way. All right, let's talk about this one here. Now, this one does not give us our function in terms of y. We got 3 over x. But notice that I've got a y equals 1 and a y equals 3. That might be an indication to you might need to do it with y's. So a graph is going to be needed here. So if we think about graphing this, I know my y needs to go at least up to 3 here. And if let's graph all my straight lines first. I have x equals 0. X equals 0 is the y-axis. And then I have y equals 1. What type of line is that? Horizontal, at 1, right? So that's this line right here. And then I've got y equals 3. And so y equals 3 is this horizontal line here. When you've got 2 horizontal lines right there, there's a good chance that it would be easier to do it with y's because you're going to be looking at this from 1 to 3. Not always, but a lot of times. So let's think about graphing f of x equals 3 over x, right? And let's think about just plugging in some numbers here. 1, 2, 3, 4. Okay. So if I make myself a table for this, I got x, f of x. If I plug in 0, what will I get? It's undefined, right? Because if I plug in 0, I'll get 3 over 0. It'll be undefined. So 0 would be undefined. That's unhelpful for my graph. It does tell me I've probably got a vertical asymptote there. If I plug in 1, I will get 3. So the point 1, 3. It's right here. If I plug in 2, I get 3 halves or 1.5. So 2, it's going to be 1.5. That'll be about right here. If I plug in 3, I get 1 right here. So what I'm looking at is I'm going to have this graph right here that's going to look like this, roughly. So the area that I'm looking for, let's do yellow. The area that I'm looking for is this area right here. Now, if I'm thinking top minus bottom, which function is on top? Is the black one always on top? The black one is on top here. What about over here? It's the red, right? So you can do this with x's, but you're going to have to split it into 2 separate sections. So if you do it with x's, you would have to split it right here. However, which one is furthest to the right? The black. And which one's furthest to the left? X equals 0, that y-axis, right? So since I have a function that is always furthest to the right and the other one's always furthest to the left, you can do that more easily if you do it that way. So to do that, I first need to solve this equation. This is right now is y equals 3 over x. I need to solve it for x so that it's in terms of y. Because if I want to do right minus left, I have to be using y's, not x's. So if I want to solve this for the x, I can't solve for x when it's in the bottom. I will multiply by x here and x here. So that will give me xy equals 3. And I'm trying to get the x by itself, so I divide by y. So x equals 3 over y. So this black function here, it could be 3 over x, but it also can be called 3 over y if you're doing x equals. And that's the one we want to use if we're doing right minus left here. So to integrate this, I would take the right function, which is 3 over y, minus the left function, which is just the y-axis, which is 0 right here. So you can write that or not. It's unnecessary. dy. What would be my limits on my integral? Not 0 to 3. What's Kayla doing? She's looking at the x-axis. What are we supposed to be looking at? Y-axis. What's the lowest point on the Y-axis? 1 to 3. I'm glad you did it wrong because everybody does it wrong. And so that's a good time to point it out that if you're doing a dy on the end, you got to look at the y coordinates there for your limits. So that 0 is sort of unnecessary. How do we integrate 3 over y? If I make a y to the negative 1, and I try to integrate that, the 3 is just a coefficient, but I'll do y to the 0 power, and then I got to do 3 divided by 0. But can I divide by 0? No. This should remind us that this one is something special, and it is natural log. The 3, you can even like pull the 3 out as a coefficient if you want, and just make this 1 over y dy, like that. And when we integrate 1 over y, we get natural log. So 3 natural log of the absolute value of y. And we'll evaluate that from 1 to 3. So that will be 3 natural log of 3 minus 3 natural log of 1. But what is natural log of 1? It is 0, so 3 natural log of 3 is just your answer for that. Okay, questions? Now let me just show you really quickly. You can do this with x's. I want to kind of point that out. You can do this with x's, but it's going to be harder to work out. It's going to take you more work. If you do it with x's, you got to split it right here, okay? Because you have a different top function. So if you do it with x's, you got to integrate from 0 to 1, because that's 0 right here and 1 right here on your x-axis. You would do top function, which is 3, minus bottom function, which is 1 dx. That would be, this blue right here would be this area right here. Then you would have to integrate from 1 over here to 3, because this right here is at 3. And then you would have to do top function, which is 3 over x, minus the bottom function, which is 1 dx, like that. This will give you the same answer, but it's going to have a lot more work rather than just integrating 1 over y, 3 over y dy, right? It's going to be a lot easier to do it this way if you do it this way. But if it were for response and you did it this way and you did it correctly, you get full points for it. Okay, questions? Okay. All right. So find the area of the region bounded by the graphs of x equals negative y minus 1 squared plus 4 and 1/2 x minus 1. Okay. This particular function, this one is a x equals, this one is a y equals. Which one do you think we're going to need to use? The x equals or the y equals? Can we solve this one for y? Only if we take a square root of both sides and get a plus or minus, right? So that one's going to be hard to solve for y. This one, on the other hand, can be solved for the x fairly easily because it's just a line, right? We can change it pretty easily. So, for this one, you got to think about what the graph would look like for this one. We probably didn't do enough of this in pre-cal for you to be very proficient with it. Does anybody know what this like minus 1 right here is going to do? It is not to the right one. It's up 1 because the y is the variable that you have in there. So we probably didn't do enough of this in pre-cal that we know how to shift these very well. The 4 right here actually moves it to the right 4, and that negative means it's going to open to the left. But we probably didn't do quite enough. I do want you to be able to recognize this is going to be a sideways parabola. We can do, setting these equal isn't very easy either, is it? First of all, we can't set it equal unless we got this over here solved for x. So we would need to add 1. Let's do that first. Let's add 1. We got to do this either way. Y plus 1 equals 1/2 times x. To get rid of a 1/2, we could divide by 1/2. But dividing by 1/2, dividing fractions is easy as pie. Flip the second, multiply, so it's the same as just multiplying by 2. So you got 2y plus 2 equals your x. Let's do it without a graph. We'll do it without a graph. All right, so we want to see where these cross. We need to set them equal to each other, right? So we're going to say negative y minus 1 squared plus 4 equals 2y plus 2. It's not the easiest. What do we need to do? We could, or 2. We could put those together. We could divide by that negative, so now we've got y minus 1 squared equals, it's going to be negative 2y plus 2. Now, the next thing you might be wanting to say is what? Square root. But if we square root, we're putting that y underneath the square root, and we want to solve for y, right? And that is not going to get us anywhere, because then we're going to have to square it back to get rid of that. So let's do this. Let's square this out. Y squared minus 2y plus 1 equals negative 2y plus 2. Or we could have done that from up here, expanded that. Now what should I do? Okay, let's move everything to one side. Well, actually, if I move that 2y right there, it actually just cancels out on both sides, right? So now I've got y squared plus 1 equals 2. You could move everything to one side and factor, or you could just, in this case, subtract your 1. Y squared equals 1. I will square root both sides. What will I get? Plus or minus 1. So negative 1 to positive 1 should be my intervals. Okay, so I'm going to be integrating from negative 1 to positive 1. Which function should come first? That is not so easy to tell, right? Especially since we're not very we know what this line looks like, but we're not really familiar with this graph right here. But I know I'm going from negative 1 to 1, so what's a good number to pick in between? 0 is your easiest. Plug in 0 into both of these. So if I've got negative 0 minus 1 squared plus 4, that's going to give me negative 1 plus 4, which will give me 3. So if I plug in 0, I get 3 right here. If I do 1/2 times 0 minus 1, I get negative 1. Which number's bigger? The 3. So that means that this one should be on my right. Oh, yes, yes, yes. Oh, I've messed it up. Let's see if it makes a difference. I don't need to plug it into my y equals equation because I'm plugging 0 in for y. I plugged 0 in for x right there. Oh, that was bad. Let's go down here. We need to plug in 0 for y here. 2 times 0 plus 2. Oh, that's going to give us 2. Actually, I would have gotten lucky there because it is still the quadratic that's going to be on the right for this one. But if I got like a 4 right there, then I would need to do the line first. For sake of time, we're going to set this one up and we're going to leave it. Sometimes the questions that they give you will ask you to set it up and leave it. They won't ask you to actually solve it, and we need to do the last couple other things I've got. So we would take negative y minus 1 squared plus 4 minus, make sure you use the y version of this, which is 2y plus 2, and we put dy over here on the end. And that would be a lot of expanding and putting those together and then integrating there, and you would eventually get an answer. But we, for the sake of time, are going to leave that one there. So a lot of the questions you'll get on this, because these can be so lengthy, won't even ask you to solve for the final answer. They'll just ask you to set up the interval for that. All right, I got 2 more problems we need to look at real quick on the second set of notes. And we're going to use our calculators on both of these. The picture here on this next one is not good, but it'll be okay. So we are supposed to find the area of the region between the graphs of f of x, which is a cubic, and g of x, which is a quadratic. But if you look at the graph of these, they don't cross just twice, they cross 3 times, right? Or, well, yeah, 3 times. They intersect 3 times. Meaning that the function that is on top switches, right? So, to do this one totally by hand would be like a lot of work. So, let's look at my 2 regions here. So, this region right here, we'll do in blue. I can do top minus bottom. I don't have to do left minus right. In fact, left minus right would be hard on this one. I'm going to do top minus bottom. Which function is my top function? The cubic or the quadratic there? The cubic. So for that section, I would do, I'm going to call it f of x minus g of x. And we're going to treat this like a calculator active problem. So that's all we have to write right there. We don't have to actually put the numbers in. If it was one you were doing by hand, you would need to put them in, but we're going to use our calculator so we can put those in. What should be my limits for that? -2 to 0, right? We're looking at the x-axis, the furthest to the left over here, that x-coordinate is -2, and 0, 0 is where we cross here. So that gives me this area. But once I get past 0, the function switch, right? The one that's on top switches. So what I would need to do for this area that I'm going to do in red right here is I would need to switch it. So I'd have an integral where I'm doing g of x minus f of x dx. What should my limits on that be? 0 to 2. So we're going to use the calculator to do this one right here. And I think it is much easier if you, when you're using your calculator on this one, calculator, there it is, if you use y1 and y2. I think it makes it a lot easier to do this problem. So I am going to go to y equals, and I'm going to type in 3x to the third minus x to the second minus 10x. And then I'm going to go to y2, and I'm going to type in -x to the second plus 2x there. So, for this, I can go back to my main screen here, and I can integrate. And if I do that first part, I'm going to do y1 of x minus y2 of x. And I'm going to put comma x, comma -2, comma 0. And you could do the second part here as well, but sometimes I'm just afraid of getting too much going. So that area right there in blue is 12. And then if I go back and I switch it, I make it y2 minus y2 1, and I go from 0 to 2, I will get another 12. Those don't necessarily look like they're the same size, but they don't look like they're not either. And so you'll get 24 for your answer there. That's one that could be done by hand, but it would take forever to do it by hand.
Would it be, is it better to break it up like you did, or did you just put it all together in one big thing?
You cannot put it all together on this one because, you mean typing it in?
Yeah, like I just
It doesn't matter, just whatever you're comfortable with typing it in. It has to be 2 separate intervals, though. You can't put the intervals together. Yeah. Yeah, but typing it in, it's just your preference on that. Sometimes I'm afraid of, like, getting my parentheses mixed up if I'm putting too much
the
in.
first time I put it in, I got 0.
Yeah. Okay, let's look real quick at this next one. This is an ancient problem, but it's a really good problem because it goes from 1960 up to 79, and it came from our textbook, the old textbooks I had that were like written, copyrighted in like 91 or something like that. It was crazy how old they were. So I'm going to go to y equals real quick. I'm going to type in both of these equations. No, we're cutting it close on time, but this is a good problem. I got 0.18x plus 5.38. And then y2 is negative 0.0029x to the third plus 0.149x squared minus 2.4642 x plus 18.38. Okay, so petroleum consumption patterns have changed in recent years. This is obviously not recent years, but it was when this problem was written. The rate of consumption in billions of barrels of petroleum in the United States from 1960 to 79 is modeled this way. And they're calling that from negative 10 to 9. So they're letting 1970 equal 0 for this. And so it makes sense, like during that time, more and more people were getting cars, right? Like probably most people in the 60s had a car, but you're looking at a time where like families are probably starting to get 2 cars instead of 1. The population is growing, so you're seeing car usage increase. Then from 79 to 93, you can use this model, right? And you probably are starting to see some changes here because in 79 is when they start making some differences in like emissions and stuff like that. So the pattern may not be strictly linear anymore for that. So if we graph this, we really need to look from negative 10 to 23. So our window, we are going to go from negative 10 to 23. And then once I get my window X's right, what should I use to get the graph right? Zoom fit. So I'm going to go F2 and down here to A, which is zoom fit. And hopefully it's going to graph it for us. There's our line. There is our cubic that we have here. And it says, find the total amount of fuel saved from 1979 through 1993 as a result of the fuel being adjusted right here. So what we're looking at is from 79 to 93. We're looking at the difference in our fuel consumptions. These are rates. This is your barrels per year. So we want to know about like total number of barrels, right? So we would integrate for this. So for this function, for these functions, we would need to see where they cross, and we're going to run out of time, so we're not going to be able to do this one. But we're going to see where they cross. We'd be integrating top minus bottom and figuring out the savings there, but we're out.